Uh, yes. Good morning, professors. Welcome back for the next session, or programming in data science for data visualization and other practices. We have Dr. Durai Raj Vincent, Associate Professor, VIT University, Vellore. He completed his doctorate from VIT University. He has a very good publication record of more than 60 papers in SCI and in Annexure journals. He produced two PhD scholars and currently guiding six research scholars. He has published four patents and two book chapters. Thank you so much for joining us, sir. The session is yours, sir. Thank you.
Yeah, thank you very much, ma'am. So, first of all, I would like to thank SKCET professors, Professor Kavita Rani, and other organizers for inviting me to deliver a session on our programming and data science for data visualization and for other practices. So, I hope in the previous sessions you got into data science in various dimensions. So in this particular presentation, so I'll be touch upon a few introductory things related to data science as well as machine learning. Then I will switch to R programming completely. So it is not going to be something which is going to be completely related to data science. So I will spend some time on introducing you to the R programming. So I guess many of you may be not much familiar with respect to R programming concepts. So some introduction towards R programming and how to work with that. Then we will go into the concept of exploratory data analysis as well as to the visualization part. So how we are able to do visualization in terms of exploratory data analysis and how we will be able to understanding the data and all those stuff. So we will be covering towards the end of this particular presentation. So when we looked into data science, I need not explain much about the field of data science because you have been attending several sessions related to this. So a very few things. So data science, it is going to be collection of many things. It starts from data analysis to data visualization, the involvement of mathematics, web scraping, machine learning, several programming languages, IDEs, deployments. So everything together, we will be calling it as a data science. So when it comes to data analysis, so people who will be working in all these dimensions will be working in the field of data science. So it is not only restricted to only ML or only deployments or something like that. So it covers everything. For example, if you look into data analysis, so there are fields like feature engineering or data wrangling, EDA. So several things are involved with respect to this data analysis. So when it comes to visualization, so we have several exclusive visualization tools are available like Tableau or Power BI or something like that. So those things are coming under data visualization, and mathematics is mainly part of this data analysis part in terms of data science when it comes to statistics or linear algebra or differential calculus. So all these are part of data science. So one who work with data science involves these particular fields also. So when it comes to programming languages, so you all know that the role of Python followed by R or Java, which is heart of the programming as far as data science is concerned. And deployments, so probably we all know that the involvement of cloud computing, clouds like Amazon Web Services or Microsoft Azure and all those things part of data science. IDEs like RStudio or PyCharm, Jupyter Notebook. So all these are part of data science, and we have machine learning also. So machine learning integrates all those things when it comes to mathematics or data analysis or visualization on all those things. Machine learning closely related to. So we will be touching on all those aspects in a very introductory manner before we switch on to our core discussion, especially on R programming. So when it comes to the overall framework, if we look into the framework, so always everything starts with the business need. There is always a business need when it comes to data mining, when it comes to machine learning, when it comes to any kind of analysis. So there is always a need for certain things to be explored. So that's what the starting point. So when there is a business need, so always we will be looking for some kind of prediction engineering. So we need to work on what we are going to predict from that. So especially when we go into the prediction part, obviously the requirement is the data. So when it comes to the requirement, so we will be looking for historical data. So when we are going to have a rich amount of data, so when we are going to have a considerable amount of data, then only we will be able to build a successful model. So our business need will get a satisfied answer for the future directions and all those things. So when it comes to the prediction engineering, the next step is going to be the feature engineering. So why feature engineering is something very important is we have to be very selective. So when it comes to the selection of features, it plays a very major role. We cannot consider all the features that are available in the historical data. Why? Because some of the features are redundant. For example, date of birth and age, or some of the features are simply collected. For example, when it comes to a loan approval process, someone's blood group may not be sufficient to make a decision. So those kind of feature engineering is something very important when it comes to feature reduction or feature selection, dimensionality reduction. So many processes are involved in that. So the pre-processing steps only we are going to discuss today as part of exploratory data analysis. When it comes to data cleaning or data pre-processing and all those things, we will be discussing in those things. So feature engineering is something very important as far as the model building is concerned, because recently I had a word with a professor who have continuously working for ICMR. So they were sharing their experience, like 85% of their total work to complete a project they are putting only on this feature engineering part. Even recently we also had an experience when we worked with a gene data. So when we used a gene data, if you believe it or not, it has more than 30,000 features. So more than 30,000 features are available with respect to that particular data. But when it comes to data records, it was between 300 to 400. So the number of records were considerably less, whereas number of features are an unimaginable number. So something very important with respect to the whole process covers in the feature engineering part. So that's why in today's presentation also I just want to iterate on this particular part rather than the importance of machine learning modeling. We have to look into this particular part in a brief way, maybe the given time. So we will be trying to see something very relevant to this particular part. So quickly into machine learning. Some of the people had always feel that machine learning is something very new. It has come only in this particular decade or later part of 2015 or 2017 like that. But it has a very long history to look into machine learning. So especially in 1959, Arthur Samuel, one of the pioneer in the field of computing, he has defined machine learning is a study that gives the computers the ability to learn without being explicitly programmed. So that's how he has trained a checkers game when he was unable to play with the computer, and he was unable to beat the computer. So he has written an algorithm by observing the steps played by the computers itself. So that's what the starting point of machine learning. So 1998, yeah, Tom Mitchell is one of the pioneers person who is a pioneer in the field of machine learning. So he has defined machine learning in a very simplistic form that anyone could understand. So machine learning happens whenever there is a improvement of its performance over the experience it is going to get. So over the period of time, the amount of experience it is going to get, there is going to be an improvement its performance towards the task. So that's why he has defined the three parameters TP and E, task, performance measure, and experience. So over a period of time, so you will be able to increase the performance with the experience. So that's how the task is going to be achieved. A simplest example to understand this is spam filtering. So all our email services are providing a spam filtering. So spam filtering is about filtering all those spam mails from the legitimate mail. So over a period of time, so we will be always able to evaluate the performance of this particular filtering approach. So what will happen when it comes to the process of filtering? So there will be always a failure happen. Sometimes spam mails also may come into the inbox and all those things. So what kind of experience we will give it here is we will just inform the filtering system to mark it as a spam mail. So that is what the kind of experience we will be giving. So when such experience is given to the system, so it will be expected to perform better when it comes to the next time when such emails are coming. So it will be able to understand that. So that's how we will be easily able to relate to the process of machine learning. So why, which is very popular now. So yeah, when it was there in 1959, it was defined. In 1998 itself, there was a clear definition. But then why it is so popular now? Because of all these reasons. So flood of availability of data now. So the data is created like anything. So we are in a position to introducing newer terms for the data size. For example, petabytes, zettabytes, and all those things. So such a huge amount of data creation is happening, especially we are in the era of 4G to 5G. So we are just in a transforming position. So at this particular point of time, even we are going to engage even more with the data, because 5G, we know that internet of people to internet of everything. So we are going to have a paradigm shift. So the shift is going to happen, which is going to enable all the devices also, all the physical objects also can have the access to internet. So in such cases, so the data generation will be huge. We could not even imagine. So that is what the focus we are going to have when the paradigm shift is going to happen. So it is going to be even more challenging in the future to handle all those data. And second important reason is increasing computational power. So when in the earlier days, when you want to use some higher computational power, we have to travel. So only in the bigger cities and only in the bigger libraries will be only having the higher computational power. So it was something very difficult to access. Now the change, the trend has completely changed. So now even a small laptop can have a GPU computing facility with a very affordable price. So affordable price means something one could spend. So that's what I refer to. So in this particular connection, so we have more provisions to handle this particular data. So that's why it is popular. And third thing is growing progress in available algorithms. So if you look at any research publication, those research publications are involved with some of the existing algorithms. So existing algorithms were present for 10 years, 20 years, 30 years, 40 years. So that much old algorithm, but still it is able to handle. So that's what the growing progress. So we are in a position to introduce a lot of newer terms: hybrid algorithm, ensemble algorithm, embedded algorithm. So a lot of trial and error, a lot of permutation and combination, everything is happening with respect to that by the researchers, so which is really helpful for the people who are working in that. So deep learning is one such example. So if you see neural networks, you have been using for more than 30, 35 years. So now a new term is coined like deep learning. by introducing so many number of lakhs and lakhs of hidden layers, so which will be able to be handled by the GPU computing facility, and all such available things has increased its familiarity. And finally, the increasing support from the industry. So industries like industry giants are investing, like Google, from Facebook, and all those people are investing huge amount of money towards this particular field. So that's how this is very popular than before. So that's what we will be able to understand. So a simple understanding between data mining and machine learning is, data mining will be always focusing on some of the known properties that was already in a hidden nature. So whereas machine learning will be always looking for the unknown properties. So all those hidden insights are something very important for the field of machine learning when compared to data mining. So when it comes to application, so you can see A to Z, almost all the fields are getting benefited from the field of machine learning, starting from agriculture to bioinformatics, chemical informatics, or something related to the computational anatomy, networks, telecommunication, computer vision, internet fraud detection, machine perception, medical diagnosis, economics, insurance, finance, all those recommendation systems, online advertising, sentiment analysis, speech, handwriting recognition, financial market analysis, health monitoring system, time series forecasting, syntactic pattern recognition. So much of application. So we cannot leave any single thing. If you start whatever we are using in a day-to-day life, from hula roba stuff to Google Maps to Facebook, everything, whatever we are doing in a day-to-day life, everything has a reflection of machine learning. And whatever the kind of advancements we are seeing there with all those applications, all those things are benefit of the data science or machine learning. So that's what we are enjoying in our day-to-day life. So now we will quickly move into R programming, the second, the what we are about to see in today's session. So quickly we will cover up some of the basic programming with respect to R. Then we will be looking into some of the advanced things, not so advanced. So I don't want to go such advanced things. So I just want to create some kind of interest towards this programming language, so that in future, when there is a requirement at your end, you may be in a position to also adapt to a new programming language, which is very simple. So the one important reason to select this is it's very simple, and so much of availability of all those help manuals are available. So first, when you look into the origin, so Bell Labs, which is very popular, even states, even all of us know that, which has developed a statistical analysis package. So we have to understand that it is mainly for the purpose of a statistical analysis rather than for the machine learning and all those things. It was introduced as a towards the focus on statistics. That's why it was named after Yes. So there was a subsequent implementation of such package in a open source format that was called as R. That's what a simple reason. R stands for nothing. It was just a complement to what we had as Yes. So it was created by a group of people at the University of Auckland, New Zealand, which was developed at that particular university. And the first names also, the two persons who plays a role in this particular thing is Ross and Robert. So these two people also starts with R. So that's also the reason for the naming of R program. So this is something important. So why I have to learn R program? So always we will be very reluctant to learn something new, because we are always comfortable with what already we learned. So these are all some of the main reasons why we should also have R. So as I said, it is not going to be the replacement of anything. It will complement whatever there already. So this is also will be available as an option. So the simplest thing is style of coding is quite easy. So anybody can learn. Even somebody who don't know coding also can do R. So I don't know any programming language, I can learn R. I know many programming language. Still, it is very easy. So I can learn R. So in all the ways you have the answer for learning R. And it is open source. We need not pay anything. And the most important thing is we have the availability of instant access to more than 16,000 packages which are customized for various computational tasks. It is like the functions we used to call. So when we call a predefined function, so it will automatically work. So that's what here it is refers to. More than 16,000 packages. We need not write a piece of coding for all those tasks. So straight away, if we call that particular function, so it will execute. So that's what something very simple with respect to this R programming. The next important thing is community support is overwhelming. There are numerous forums are available for all such supports. So people across the globe will have the conversation there and get high performance computing experience. So it when it comes to using this, you will not see much delay in terms of processing and all. So even with a simple laptop, you need not go to a GPU computing and all. So anyway, I will show those things. And one of the highly sought skill by analytics and data science companies, one of the here there is no false claim and all that this is number one, this is number two and all. So always in last 4 to 5 years, if you see, always R programming also will be there in top 5 or at least in top 10. So one of the short skill. So it is always to go with if it is comes to student practice, so we can go straight away with the R programming console. But if faculties and researchers can straight away go and work with R Studio, so it is always a better one. So which has a very good IDE wherein which we will be able to see all those things of execution to outputs and all those things. And more than anything, we need not go and type everything. So like a visual basic kind of console, so we'll get a lot of help things also whenever we type. So that is what the kind of advantage we are having with respect to R Studio. So this is how an R Studio will look like. So R console, R script, R environment, and graphical outputs are there. So in consoles, we will be always able to see the executions, whereas the scripts will be written at a particular part. And in our environment, we will be always seeing what is the kind of execution happening in that, whereas the graphical output space, so especially today we are going to more, our focus will be more on visualization part, so we will be able to see those things in this particular part. So when it comes to the basic commands, so you will be able to do all kind of basic commands with respect to that. So it is really good at dealing not only with the simple execution. So whatever it may be, the group of numbers, vectors, matrices, all those basic mathematical things, we will be able to do it with the help of that. It's very simple with the help of the multiple operations or multiple brackets and all those things we will be able to do. So that's why we will be very much starting with something very simple. So if you see 2 plus 4 here, so immediately you will be getting the result out of this. So this is what you will be able to see. So here it is a simple math, so you will be getting the output here. So if it is something beyond that, so when we are going to work with the data set and all, so you will be getting some kind of execution details in the environment side. If it is about something relevant to the visualization output, so we'll be getting the plots out of here. So it will be very simple. For example, I want to execute this. So a simple copy paste here. So if I'm going to press enter, so I will be able to get the result out of this particular execution. So that will be up to any number of things. For example, if I want to find the natural logarithmic output of 12, I can just type like this. Or if I want to find the square root of some value, so that also will be executed again. The time of getting the results here will be very quick when compared to the other programming languages. So these are all something very basic commands. So beyond this basic commands, if we want to have a variable, so normally we use a variable, so which will vary time to time, and which will be also used for the other calculation also. So here also those variables can be used like this. For example, if I want to have a variable as x, so wherein which I will be performing some operation and I will be storing the value in that particular variable. So it is as simple as this. So we will be using this particular symbol, which may be new to many of the people. So if I execute this, so it will add 8 and 7 value, and it will just store the value of this. If I give x, it will give the result of that particular addition value. So that's simple. This particular calculation is. So once this particular variable is created, so we will be able to directly use that particular variable continuously for several times. For example, here if you see, I have used a particular variable called answer, which is equal to 2 plus 2. So the answer will be 4. Then I can keep on use this particular variable like any other programming language we have used. For example, another object called answer2. So there is a calculation 3.5 plus 1 to the power 2. So basically 4.5 to the whole square. So that's what the answer to value will be. So again, when we want to add these two objects, it can be performed, or else the combination of those two objects can be worked on a particular operation, and that can be stored in another object. For example, answer 3. So all these executions, so we will be able to do it with the help of that. And at one particular point of time, for example, there are several objects are used here. So when we want to list all those objects used at a particular session, so list it, the short form is ls, open bracket and close bracket. If you give that, it will just display the number of things here. So far we have used only one, so it will be only displaying x as the result. So when we are going to have so many number of objects that are used at a particular point, so it will be in a position to display all those things. So this is again something very introductory thing with respect to that. And if we want to remove a particular object, then we can use this particular function rm. So rm, within a bracket, if you give the name of the object, then again, if you perform the list operation, then you will be able to see that there is an object called answer2 was already got deleted. So next important thing is functions. So as I said, there are more than 16,000 packages that are available for processing, especially huge computational tasks. So when it comes to plotting a graph also between two attributes, or between more than two attributes, if you want to plot a graph from a very big data set also, you require only one line code. So that is the beauty of R programming, because that particular function will handle everything. So it will call all those codes written for executing that particular function. So that will be something really very helpful for that. So that's what explained here. So R comes with a huge variety of short ready-made pieces of code that will help us to manage our data. It does more complex mathematical operations on our data, on particular aspects. So also it draws graphs and carry out a statistical analysis ranging from simple to many straightforward functions to the complex one also, because as you all remember that basically it talks about statistics. So statistics analysis, so all basically it was developed for that particular purpose only. So only at later period of time it has enhanced towards accommodating all those machine learning functions. So basically, it was developed for that particular purpose only. So these are all the simple example of functions. For example, logarithmic function or exponential function. So all these things we can simply call these, for example, square root or absolute. So round functions and all those things. So this round functions, it talks about to up to what digit it wants to round this particular value. So 537. So that's why the result is 54. So it is up to one digit, means it will be only 14.5. So like that, several functions which are available to handle this. So that is about something very basic to R programming. For all these functions, naturally we don't require a programming tool and all, because normal calculator itself is having all those things. So we will be moving to the next step on what also could be done with the help of R. So especially here we are going to see the various types of data that we could handle with respect to this. So especially for the so initially we will be seeing how data will be created in our programming console itself. Then later we will see how we are going to import the data from our system or outside system. So how we are going to import the data to the R console and how we are going to work with that. So initially we will see how data can be generated using R programming, because some cases we may require data generation also. So data generation is something very important in recent days, where in which some areas, some niche areas where we don't have sufficient number of data. So for handling those data creation is something happening in recent days. So that is also something important with respect to R programming. So R supports various data types, includes numeric, integers, and all types of characters and everything. So not only that, it will be we will be able to work with matrices, we will be able to work with data frames, a list. So everything we will be able to handle with the help of R programming. So that's what we are going to see here. So we will see one by one. So first type of data type what we are going to see is vector. So in vector, so we will be able to use a function called a sequence, so seq. With that, we will be able to create number of digits, a particular range. So the range is given 1 to 10. That is what the range. So that's what given here. So those values will be stored in X. So here X is the object, the sequence is the function, and the range is given. So when it comes to give this particular range, so we will be able to create those numbers, for example 1 to 10. So you will be able to create this. So next way how we will be able to create, so I don't want to create sequence of numbers. For example 1 to 10 I don't require. I may require only even numbers, I may require only odd numbers, or I want some random numbers should be saved. For example, here the second example is there is a way of storing set of numbers into a particular object, for example y. So where in which we are giving the numbers, all the even numbers from 1 to 20 is given here. So all these values are given here. So now with respect to this particular vector, so we will be able to perform certain operations. For example, if you look at the previous slide, there is X. So X sequence of 1 to 10, it is created. So now I am executing this particular code, X plus 3. So simply 3 is added to X. So what will be the result of that? The 3 value will be added to all the values available in X. So that's how this vector will work. So similar like that, already there was two vectors, so I can perform X multiplied by Y y divided by x. So all those things with respect to two vectors. So set of numbers in first object, set of numbers in second object. So when I am able to perform this, so it is possible to do this. For example, yes, we can see this also. So how it is done. So so we can create here, yeah, already there was x, now we have again used that same x. So since the recently we have done this, it will be taken care. So the next we can have y also. So anyway, y will display whatever the input we have given. So when we want to do a simple operation like this, so we will be able to see that the value 3 is added across all the positions. So then we can work with these kind of operations also. For example, y divided by x. So you will be able to see that the y value, the y vector is divided by x. So that's what here we will be able to see here. And beyond that, for example, we have seen that the x variable was created with the help of a function called a sequence, and second one was not so, where we have given all the numbers as it is. For example, if that is what the case, so you have to add only the odd number or even number. So there is a way of doing that. For example, here the sequence of 1 comma 10 by 2, which means with the difference of 2. So that's why this x2 consists of only 1 3 5 7 9. So with respect to the two difference, all the values are listed here. So now you can further perform these operations. For example, x plus x2. So x plus x2, if you see, x was 1 to 10. So that's what we have seen. So x2, if you see, there are only 5 numbers are there. So first one, it has 10 numbers. Second one, it has only 5 numbers. So how the addition will be means, first 5 values, it will add whatever there in x2, then again it will repeat all the 5 values. So that will be also added here. So that's how we will be able to see this particular thing. For example, for all this set of numbers, you want to find the logarithmic value, for example 1 to 10, or else you want to create a logarithmic table itself for up to 100 numbers or up to 1000 numbers. If you want to immediately create it, so just you can create a sequence from 1 to 100. Then if you call this logarithmic function log of x within the bracket, and if you store it in any particular object, it can be log x or anything. If you call that function, so you will be able to see all the logarithmic value of numbers 1 to 10. So that's how that's simple this how we will be able to perform this operation. So next thing is about matrices. So matrices will be created in different ways. So matrices in a general term, but normally we can call it as a list or a table also. So yeah, in a table also we will be having only rows and columns. In matrix also we will be having that. So there are several ways of creating matrix in R programming. So first one is so simple and straightforward one. So we will be using this matrix as a keyword or a function name. So where in which we are going to tell that there are going to be 6 positions available in this particular matrix. So next we will be telling how many rows and how many columns. So here we have not given very specifically the value. So we are just given only the sequence. The values will be from 1 to 6. But what is the only difference normally in other matrix function and here in our programming is, normally any matrix will work on row major way. So which means the values will be entered in row wise. But here the difference is the value will be inserted in column wise only. For example, 1 to 6, if you see 1 2 3 4 5 6, so it will work in column major. So that's how it will work. So again a simple code. So we can generate a simple matrix here. So if I type my underscore, so here I am getting the help. So just I am clicking and I am just getting that particular matrix. So that's why I suggested that RStudio will be much more convenient for all those things, but which may not be helpful for the students. So students also will start get all the help. They will not remember anything. So for students, we cannot go for our studio. So when the matrix is created, so I here it will be already we only created. So just to understand the dimension of this particular matrix, so you will be able to see that there are 3 rows and 2 columns. So that's what the matrix we have created. So here the function to know the dimension 3 and 2, but in a larger data set, so this will be really helpful. So when I am in a position to import a high data record data set, then this dimension function will be really helpful, because any data set when you are going to present to the outside world, they will be asking only the first question is what is the size of your data set. So always your rows will tell that how many number of records are there, and always your column will tell that how many number of attributes or features are there. So which will be derived in a very simplest manner. So next, for example, is it the only way of creating the matrix? No, it is not. So for example, I have created a particular object. For example, earlier I have created 2 objects as X and Y with a sequence. So that particular sequence, it was given in 2 different ways. One was as a sequence itself, 1 to 10, and second one is only the certain numbers I require. So that's why I have given. So here in this particular case, for example, I have created an object called age. So in that particular age, some numbers are there. So that I will be storing in the particular object called age. So now in a very simplest way, I am converting this particular object age into a matrix. So how I will be doing is just I am giving this dimension function. Again, I am using here with respect to this, and I am just giving the dimension of this particular matrix is 2 rows and 3 columns. So whether it is 3 rows and 2 columns or 2 rows and 3 columns, it will always enter the value column wise. So that's what here you will be able to see 23, next 44 here in the column, next only it is 15 and 12, next it is 31 and 16. So like that we will be able to do that. So after converting the object into a matrix, so here if you want to check what is the class of this particular object, so you will be getting this. So this is something very simple again in terms of implementation and understanding. So a simple object is created. Next we will be converting that into a matrix with the help of a simple function called a dimension by giving the size of this. So after that, if you just give that particular object name age, so you will be able to get this. So now in a simple way, if you want to confirm that whether it is really converted into a matrix, then if you give this, so you will be able to see that it is a very properly converted into that. So this is something very simple with respect to that in terms of creating the matrices. In some other way also you will be able to do. So in the previous case, if you see you with only one object you have created a matrix. So normally it is not. So we will not do like that. So normally what I will do is every object will be placed as a different row or a different column. So for example, object 1 age will be as first attributes, next maybe sex maybe as a second attribute, maybe name maybe or number maybe as a third attribute. Like that some kind of information will be there. So how such kind of things can be carried out here is, for example, again if you are able to see, there are 2 objects are created. X is the first object and Y is the second object. So X carries some set of numbers, Y carries another set of numbers. So now I want to do only column bind. So column bind means first object it will consider as first column, second object it will consider as a second column, and it will make it like a matrix. So what will be the matrix? So there are 6 numbers are there, means there will be 6 cross 2 matrix. So it will create something like that. So in such cases, in several cases, for example, here itself, very specifically I have used, for example, if you see X, it has 6 numbers. For example, Y, it has only 5 numbers. So why there is a difference? So you may get a doubt if there are number of numbers are not same, what will happen? So what will happen if you see this 20 is repeated here? So again, these values will be repeated. So that is what the nature of our programming. the way in which it will function. So that's how, anyway, you will be able to get a warning message also. So number of rows result is not a multiple vector of this. So that's what you will be able to see here. So with the warning, you will be able to do that. So here when I execute, so I will be able to do this of the creation of two objects, x and y. Then followed by that, I can do a column bind. So x comma y, if I do with respect to column bind, so there is a warning message because both these numbers are not same. Still, I will be able to get a matrix which is a combination of those two objects. So that's what about the matrices. So next, when you go to the concept of factor, so why factors are important, especially we have to understand about this. We will not be always working with the numbers, right? So especially in a data set is concerned, for example, I told sex. So what you will, your input will be male or female. So those kind of data we used to call as a categorical data or a nominal data. So only categories are there. For example, income range, they have given us high, middle, low, very low. Those kind of categorizations are there, whereas no information on what is the income specifically in terms of rupees or dollars or something like that. Those information are not available. So those kind of data also very popular when it comes to a particular data set is concerned. So this kind of data we will be always store as a factor. So that's what the necessity of having a factor to be included in this particular presentation. So in a simplest way, every data can be converted into a value which corresponds to a particular category it belongs to, because we will not keep the data as it is when it comes to processing. For example, male and female is there, the kind of categorization in the data. So we will simply assign one value for all the male and two value for all the female. So just a conversion. So that kind of conversion into a numerical value will be very helpful for processing at the model building exercise is concerned. So such kind of things, it is something very important as far as the data handling is concerned. So that's why we are considering here a new object called x1, which consists of several colors, for example red, blue, green. So there are three categorization of colors are there, RGB. So here I am just converting these colors into a factor. So factor means some equivalent values we are going to consider for each color. So how it will be done is we are going to store that in a new thing as x2. So we are just going to convert this into a factor. Then how we will be seeing all these values is in terms of numerical value as dot numeric of this x2 value. So there will not be any change in x1. So x1 will be stay as it is, like with the colors whatever was introduced. But x2, if you are able to see, you will be able to see only the numbers corresponds to each color. So next comes the important part, that is data frame. So data frame is something what we will be able to create like a table. So in a very simplest way, we will be able to understand this as a table. So how we are going to access a particular table, because most of the time we will be in a position to access the data than creation. So creation may be a 5% task with the help of any tool, but accessing those data is remaining a substantial percentage of work that we will be doing with the help of that. So that's what we are going to see as part of this data frame. So it is going to be used to store the tabular data. So any data which is in the table form, you will be able to store as a data frame. So it is completely different from a matrix perspective, because matrix is something else that will be always accessed with the help of a row position and a column position, all those things. But a data frame is different, wherein which we will be able to have different classes. So different classes in the sense it could be an integer, it could be a whole number, it could be a string. So it could be a combination of everything. So that kind of things we will not be able to do in a matrix. So a simple data frame is created here. So the keyword or the function name for creating a data frame is data date frame, a simple function. So since we are creating a data frame, I have used the object name as df. It could be anything also. So there I will be creating in a very simplest way. For example, there are four categories are there for this particular data frame called gender, height, weight, and age. So all these values I am giving upfront. So this is the simplest way of creating it. So in the next example, we will take small data sample and big data sample one by one. So here, if you are able to see, there are four attributes or corresponds to this particular data frame that are given here, with the corresponding values also stored with respect to each attribute. So that's what given here. So when we are going to list those things, so you will be able to see that it is looking like a table. So it has four attributes and there are three inputs corresponds to each and every attribute. So this is something very simple to create, which may be useful when we are in a position to do some kind of demonstration. So when we give this, so you will be able to see that whatever we have inputted, we are able to see that. When you want to see the structure of this particular data frame, so you can call this again for a simple data frame. So this is only for the understanding purpose. When it comes to a larger data set, the interpretation will be little more difficult. So that's why we have done this here very particularly. So when you look at the structure of this particular data frame, so you will be able to see that there are three observations with respect to four variables. So a detailed summary, we will be able to get it here. So there are four attributes are there. With respect to the gender, there are two factor levels, that is female and male. So we are going to assign 2, 2, and 1, which means male corresponds to 2 here and female corresponds to 2 and male corresponds to 1. With respect to height, weight, and age, so it is able to see that all these are numbers and all the numbers are available here. In such a way, the structure function will decode everything and it will present all the details with respect to that. So when it comes to import, so when you want to import something, for example, here I have created a sample data frame or a sample data frame. For example, here you will be able to see serial number, sex, temperature, weight, and count. Some data, some information is available, and I have stored this particular Excel table as a .csv format, because only .csv format we will be able to access in this particular R Studio. So that's the reason why. So we will be using like this. So I have just created an object called data here to just store this particular CSV file. So when I execute this, and if I call that particular particular object data, so all these information are present here. So how I have called that is with a function called read.csv. So read.csv will get a particular file, sample.csv file, to this particular object called data, and when I call this particular object, so you will be able to see the entire file available here with respect to whatever created from a Excel file. So now subsetting, for example, there is a huge file is there. There is a huge file is there. So with respect to that particular file, so if I want to create subsets, for example, I want to filter out only the female details. For example, I want to filter out only those who are having more than 70 kgs of weight, or else I want to filter out only those who are having temperature. So like that, if I want to categorize, so that's what we will be calling it as a subsetting, which means we will be creating a subset from the original set. So that's what the meaning of that. So that's what we are going to see one by one. For example, from the original data, because you remember that the object name of the particular table is data. So from that particular table, so if we give all those weight values which are greater than or equal to 70, so those data, if you want to display, that is what he given us sub data 1. So here you will be able to see that all the weights that are greater than or equal to 70 from the original data sample, only those information are available here. So next thing is, I want to subset with respect to the number of columns also, not only with respect to the only the rows. So here that's what is done here. So this subset function will be taking care of only the particular sex which is equal to male, where in which it is selecting only the two attributes, that is weight and count. So since already a particular male section is selected, so it need not necessarily be shown in the output. So that's why we are going to show only the weight and count here, whereas the other two attributes, serial number and other things, which is not shown here. So that's what we are able to see with respect to this particular output in this particular case. And like that, we will be able to do several subsettings. So in the interest of time, I have only reduced by showing only the very few examples of doing this. So that's what about subsetting. So next thing what we are going to cover here now is frequency distribution. So frequency distribution is also something very important to understand a particular data, especially when a data is in terms of large scale. So it will be very difficult to analyze a particular data, especially in the terms of frequency distribution. So normally we used to hear about the normal distribution, bell curve and all those things. So all these are part of these particular exercises, and we will see some of the basic things with respect to that. For example, again we are going to have a kind of vector concept here, so where we will be inputting so many values into a particular object. So with respect to a particular object, so we will be able to analyze several things. So that's what here you will be able to see. So M1 is going to store several values here. So what we will be seeing one by one is, for example, minimum value. So if I want to understand from that, I can execute this. So maximum value, if I want to execute this, then I will be able to see this. And beyond that, there is a way in which you will be construct a histogram also, right? So with respect to the frequency distribution between the values, so from the minimum value to maximum value, we can create so many bins with a particular range. So this is what the way you will be in a position to get the count with respect to that. So when we are in a position to do that, you will be able to understand the central tendency of that particular data. So normally the central tendency only we will be calling it as a bell shape, right? Bell shape means so that particular curve in a particular point it will start rise up, and at a particular point it will start coming down, and at a particular point it will completely close to that 0 point. So that particular curve we will be considering as a central tendency of the particular data. So where in which mostly we will be using the histogram to understand the particular data with respect to the frequency distribution. So what is the kind of frequency? For example, there is a mark scored by a set of students, some 60 students or 70 students are there, where in which we will be in a position to analyze all those things, right? So what is the lower range and what is the higher range, and most importantly, where most of the students have scored, what is the particular range? That is what we will be calling as a central tendency. So that will be mostly working on the average values, those things are concerned. So here we will be able to position to construct a histogram. For example, hist, HIST is the keyword for that. So if we call that particular object, with respect to the color, and as well as we will be in a position to construct this. So this will be looking like a bell curve. So if you look at like this, so that is where the central tendency of this particular data sample is lies with. So that's how we will be able to access this. So frequency distribution in other ways also can be analyzed, which is called as box and whisker plot. So especially you might have heard about IQR, interquartile range, and with that particular range, so you will be able to even construct a box and whisker plot to understand that. So in box and whisker plot, so we will be using box plot. So this is what the function name wherein which we will be able to construct. Mostly it will be in a position to understand the outliers also. So outliers analysis also something important, very, very important. For example, data analysis is concerned. For example, we are using a data sample wherein which in one attribute we have stored age. For example, in the age category, there is a value called -9. There is a value called 363. So all these values are outliers, so which may be heavily spoiling the quality of that particular data. So we need to analyze those data, and we have to identify all these outliers, and especially the values which will completely confuse the quality of the data. So that needs to be very carefully handled. So this is how we will be able to construct a box plot. So anyway, at a later point of time, I will explain a very detailed explanation about a box plot and how one can interpret with respect to that. So this is how we will be able to calculate the mean value and all those things, which will be very helpful for the people who will be able to looking for the analysis of the data with respect to a particular manner in which it was presented. So interquartile range will be also calculated from any particular data with respect to a mean value, whatever we have calculated. So when it comes to that particular value, when you pass that particular value, so you will be able to find the interquartile range, wherein which you will be able to see with respect to what is the range of each quarters. So that is what given here. So what is the minimum value, first quarter, median value, mean value, that will be probably available at the midpoint, and third quarter as well as the maximum value. So that is what the setup of this particular plot. So that also we can do with the help of this. So next we will be moving to the last part of our presentation, that is exploratory data analysis in our program. So exploratory data analysis is something very important, especially the data pre-processing is concerned. So why we need to pre-process the data, and why we have to understand the data? There are so many reasons in which, for example, the first reason is data analyst people may not be the one who has generated that particular data. So they will not have any idea about from where the data comes from and what is the nature of data is concerned. And the second thing is the data in the real world is dirty. So always it has a lot of shortcomings. For example, incomplete data may be there, noisy data may be there, inconsistent data may be there, or incomplete data may be there. So all these things that needs to be handled in a very appropriate way. So when it comes to the exploratory data analysis, it will give a very clear idea on the data what we are going to consider for the particular modeling or particular problem is concerned. So that's what we are going to see here. So in this particular discussion, so we are going to consider a data set, a open source data set which is available from big mod sales prediction. So that is what the data we are going to consider here. So basically, the process involved in the whole machine learning model building starts from data collection. So data collection completely lies with a particular company. Maybe the data entry operator may be available, or somebody sitting in the billing counter is responsible for the process of data collection. And data pre-processing is something very important, which will be done at the end, wherein which a model building exercise is going to happen. So our major discussion will be rolls around data pre-processing thing when it comes to the whole process is involved in this. So this is what the data sample what we have today to for our discussion. So there are several predictor variables are available, and there is going to be one response variable, that is what item outlet sales. So the particular sales value. So always any market will be focusing on the sales part. So how to improve the sales, how to double the sales. So all those things are there. There are several predictor values are there, several predictor variables are there, or attributes are there, that are all responsible for the item outlet sales. So that's what we could understand from here. So normally any data sample if you take, we will be considering response variable at one side as well as the predictor variable on the other side. So in this particular case, so we will be in a position to handle this in a very appropriate way. So if you look at the data sample, so we will be able to see that item outside sales as the response variable, and all the remaining attributes are corresponds to this predictor variable. So this is what the data sample which is taken here, so which is yeah, open source data set available. It's a very big data set. So anyway, we will be seeing that what is the size of the data set, not by scrolling, but we will just call this. So I will be just using the word or object name as marked to read this particular data. So I'm just in the similar way how it was called for a simple data set. So here some real-time data set I have called with this particular function as read.csv. So before going to do anything, I just want to understand the data in terms of its size. So what is the size of that particular data? So dimension dim is the keyword. So I have used this. So here you will be able to see that there are 8,523 number rows are there, and there are 12 attributes are there. So from that you will be able to understand that there are 11 attributes which are corresponds to the predictor variable, and the last attribute or the last column corresponds to the response variable. So here the response variable is item outlet sales. So here when we continue handling this, the first thing what we are going to do here is we are going to see the structure of this particular data set. So what is the structure? So earlier it was a very small data set, so we were able to understand very deeply with respect to that. So here you will be getting some detailed analysis of the data set what we have considered for that. So it also starts from 8,523 observations of 12 variables, starting from item identifier, weight, fat content, visibility, types. So many types of attributes we have. Factor levels also you are able to see here. It is going to be a combination of numerical values as well as the categorical value. So such combination of data we are going to get here. So before processing this particular data, so it is important to verify the particular data in terms of understanding. So understanding is something very important. So that's where we have the data visualization. So the next discussion, so we are going to cover the data visualization part. So normally there are various ways we will be able to do the visualization. So there are 7 visualization ways we are going to see here in this particular discussion, starting from scatter plot to parallelogram. So how we are going to do that one by one, so we will be able to see here. So if you look into the visualization part, out of 7 visualization, 6 are belongs to ggplot2. So that particular library function we will be using for plotting that. So the first thing what we will be doing here is, first we will call that particular library called ggplot2. So when we do that, it will take a few seconds time for calling that particular library function. So afterwards we will be able to execute this for plotting the scatter plot. So let me explain. As I told, it is going to be only a single line of code. So that particular single line of code is sufficient for execution. So if you look into this particular code, so first thing is it belongs to ggplot. Then mot is the name of the object wherein which we have stored the particular data set. So the aesthetic we are going to consider x-axis as item visibility. Out of 12 attributes, we are considering one attribute for x-axis. Obviously, the item output saves as the y-axis. We are going to consider that, and the points, scatter point, scatter plot, it is going to be only dots it is going to have. So what is the size of each dot we have given here? What is the color of that particular dot it is given here? And yes, this x lab and y lab is to just mention that in our plot what is going to be shown in the x axis as well as y axis in our plot. And finally the gg title. So what title we are going to give for our plot, that is item visibility versus item outlet sales. So all these you will be able to see here. The color, the size, the x-axis, y-axis, title, everything is shown here. So that's what we have got here in this particular thing. So when we want to zoom it, you can zoom it like this, and even just right click and you can copy or save this particular image, and all those things we will be able to do. So in a very simple way you can modify with respect to your need. For example, you don't want to see in navy color, if you want to see in green color, you can do it by just changing the color so that you will be able to see in green color. If you are not satisfied with the size of the particular dots, then you can increase it by another 1 point, maybe from 2.5 to 3.5. So you will be able to see the bigger dots. Maybe it depends on the size of the data, what point you want to go with. For example, here it's a huge size, so definitely you need to reduce the size. If the number of samples are little less, you can increase the size of that. So that's how you will be able to execute this, and you will be able to see how it get executed. So like that histogram we can construct. So already we have seen how to construct a histogram in a different way. So here we are using ggplot. So ggplot having several other ways to handle this. So that's what here it is given. What is the sequence, what is the range, what are all the attributes are constant, and all those things are represented here, like aesthetic, histogram, what is the pin width, and all those things are given here. So when we execute this, so you will be able to see the result of histogram here. So in the similar way, bar and stack bar chart also we will be able to construct here. So here also we will be using the same ggplot for the construction of this. So here we will be only changing the keyword mostly with respect to that, and what kind of things we want to do, and mostly we will be covering what is the color you want to see, what is the x-axis, and what is the y-axis you want to see with respect to the bar and stack bar chart. So this is how the output will be with respect to the two outputs what we have considered for this particular consideration. So next is box plot. As I told earlier itself, box and whisker plot in one example. So here the real-time data itself we can consider for the box and whisker plot between the outlet identifier with respect to the item outlet sales. So here we will be considering all those ranges and all those respective things with respect to each plot is given here, with respect to the sequence also with the ranges. So that's what here you will be able to see from 0 to 13,500 with a range of every 500. So here also you will be able to see with respect to each outlet, you are able to see a box or whisker plot with respect to interquartile range. So what is the particular output? For further understanding one particular thing, we will be able to take it here. So what exactly this particular graph shows us, this is a minimum number, this is the 25th percentile, this is the medium number, this is the 75th percentile number, this is the maximum number, and these are all the outliers. So outliers also will be able to identify with respect to each and every individual representation. So what we will be able to see with respect to that. So there might be different outlets. For example, a bigger supermarket is there who will be having different outlets across the country or across the world, like Walmart or something like that. So you will be able to analyze with respect to each outlet with respect to the corresponding number. So the area chart is another one wherein which we will be able to uh, construct a particular chart in a different manner to understand the different things. So how it will be done with respect to item outlet sales with respect to the count. If you want to see only that, this is how the area chart will be there. So at a later point, I will just show you how the interpretation also goes with respect to that. So the next two graphs are something very new when compared to the other graphs. The first one is the heat map. So heat map is something helpful for understand the intensity or density of each and every representation in terms of colors. So with respect to the intensity of that particular color, we will be able to uh, understand the kind of values which corresponds to. So here also we have considered attributes for the construction of this particular heat map with respect to the two attributes. So when we are going to execute this, so this is how the heat map will present. So with respect to the two attributes, that is outlet identifier with respect to item type. So how helpful this particular heat map is, for example, with respect to intensity, if you see the lower value, the higher intensity, whereas the higher value, the lower intensity, which means the dark blue to light blue, there is a kind of continuous variation with respect to these values. So when it comes to this, so with respect to each product, we will be able to analyze. For example, outlet 10 with respect to various products. For example, meat has very lowest sold product with respect to that, whereas the fruits and vegetables or canned items having little higher impact with respect to that. Whereas if you take the same meat, so some other cases, if you see outlet 18 or outlet 45, you will be able to see that it has higher impact when compared to the other products. Like that, we will be having a detailed understanding with respect to a particular attribute with respect to other attribute. And the parallelogram is another way in which we will be able to draw this. So this is not belongs to ggplot. So for this we have to install a package called corgram. So this particular package, if it is installed, then only we can use the library called corgram to use this. So after the installing these packages, so we will be able to execute this particular code to see what is the parallelogram of this particular data sample with respect to few data attributes that are concerned. So with respect to each attribute to other attribute, what is the particular relationship? So again, here intensity plays a major role. So in terms of intensity, they are given with different colors, with lower intensity to slightly better intensity to higher intensity. So like that, there is a kind of correlation that we will be able to understand here. So correlation analysis is something very important. So especially with respect to the dimensions of each data samples are analyzed there, the role of correlation is something very important. So especially in terms of dimensionality reduction approaches like principal component analysis or linear discriminant analysis. So all those approaches are majorly depends on the correlation analysis process. So in such cases, so this particular graphs will be very helpful for understanding. So interpretations, how you will be interpret, it will be very easy to interpret after the construction of these plots. So for example, here if you see item visibility towards after a particular range, so you will not have much sales. For example, here lot of sales are happened, so here the sales number is something very restricted with respect to that. So that kind of understanding we can have. And if you see this particular bar plot, you will be able to see that the impact of outlets with respect to item outlet sales. For example, here we will be able to see that outlet 27 having higher impact on outlet sales, whereas outlet 10 and 19 are having very low sales. So such kind of understanding we can have with respect to this particular graph. As well as we can consider with respect to every aspect. So this is between item type and item outlet sales. So what kind of item type are majorly benefited the outlet sales? For example, here if you see fruits and vegetables, snacks, those things are highly popular, whereas the seafoods and other few things are not so much popular. So either they can concentrate on the popular things, or else they can boost where they are really lacking. So all those observations they can make it from that. So that is what about the data visualization part. In the interest of time, I'm going little fast. So the next thing, probably the last thing what we will be handling here is data cleaning part. So data cleaning is something very important to have a efficient model building exercise. So data cleaning is something important to handling the missing values, handling the different levels and unwanted levels, or all the mismatched values and all those things we are going to handle here. So first thing what we are going to handle here is finding the missing values. So missing values are going to be something very important that needs to be properly handled. So this is how we will be able to find the missing values here. So if you see false, that means almost 10 lakh or sorry 1 lakh, more than 1 lakh number of entries are false, which means the values are available, but there are 1463 missing values are available in this particular data. So that needs to be addressed very first, because all those missing values are going to collapse the process of doing this. So for that, we are going to find where exactly the missing values are there. So we are going to use the column summary COLSUMS for is.NA of mart, so which means where the values are not available. So when we are going to see that, here you will be able to see that only in the item weight there are 1463 entries are missing, whereas all other information are completely full. Completely full means it is with respect to only missing values, not with respect to other anomalies that are present. So this should be handled in a very proper way. So beyond that, we will be in a position to analyze the complete data also. So not only with respect to missing values. So for that, already we know that the summary thing will be really helpful for us to understand that. So here the anomalies are listed here. For example, item visibility, if you see, the minimum value is 0, which may not have any value at all. That may be an anomaly. So again, in item fat content, if you see, low fat itself is represented in 3 different values, that is LF low fat, capital L low fat. Again, regular is also represented in 2 ways, that is REG as well as REG ULAR. So these kind of things are identified here. Again, in item weight, if you see, not available, there are 1463 numbers are present here. So like that, there are several anomalies are present in this particular data sample, that needs to be handled in a very appropriate way. So that's what we are going to see at the end of this presentation. So that is what the inferences we had. For example, item fat content has mismatched factor levels. For example, LF or low fat, or capital L low fat, or REG or regular. So all those things. And again, the minimum value of item visibility is 0. That may not be a considerable one, which should not be equal to 0. So that should be taken care. And third observation is item weight has 1463 missing values. That needs to be taken care properly. And outlet size also has unmatched factor level. So that's what we are able to see here. If you see here, high, medium, small is there are about 2410 entries are there, which has no level which is mentioned with respect to that. So that is also a kind of anomaly that needs to be handled very perfectly. So with respect to missing values, so normally two ways we will be, not two ways, many ways are there. First thing is simply deleting all those entries. So out of 8,000 something entries, if you are going to delete 1,400 plus, it is going to have a significant impact, because 1/6 percentage of data we will be deleting. So that will be a bad option. So the second thing is we may go with the mean value or median value with respect to item weight, because it is going to be some numerical value. So that will be a good option to do that. And the KNN imputation is also another way where in which we will be able to do it in a very perfect way. So how we can do that is we can simply call the K nearest neighbor approach. So K nearest neighbor approach is basically a classifying approach. It will classify the output depends on the input value, but it will be really helpful for handling the missing information also, rather than going for a mean value, which will definitely give you only some kind of fillers. It will just fill some value, but K nearest neighbor algorithm will be really helpful for filling the value with some relevant information, which means, for example, there are 11 predictor variables are available, only one variable is missing. So based on the remaining 10 variable, what is the closest value that will be having with respect to that particular missing value. So if you are going to do that, so it will be really helpful of doing that. So for that, we have to install this package, that is visualization and interpretation of missing value. That is a Vim package we used to call. So that package, if you install, then if you use that particular library, within a single line we will be able to process this particular thing with respect to that. For example, I am going to store this as a big mark imputed, which means a new object name I am calling. Why? Because I don't want to disturb the earlier used marked object with respect to that, so that we will be able to see how better this particular thing is done. For example, now the execution is done. So now I have to just call this particular function summary, that is summary of so I'm going to call this. So when we are going to call this, you will be able to see that all those missing values are gone with respect to that. So that's what we will be able to see here. So there is no missing values are available. So what is the other way? As we know that the mean value also can be stored with respect to that. So that's what here we are going to do with that particular thing itself. So in that way also we can process the original data sample also. So that also is an option. So when we are going to do that, so in this way also we can see that how the whole thing is handled with respect to that. So here there were NAs are available, that is 1463. So here you will be able to see that there is no NA available. So here also, if you call this again, you will not see any not available entries that are available here. So this is how the missing values are handled here. So apart from that, we have found a few other things also. So how we are going to handle those is, for example, item visibility. Item visibility, we have found several zero values are there. So wherever zero values are there, we can again substitute the median value with respect to item visibility with respect to that. So that also we can handle with the help of KNN also. But here the missing values are not there because the anomaly is just a zero value. So those kind of things will be doing those kind of changes. So apart from that, so item fat content, we have to make changes. So wherever the LF is there, we are going to make it wherever the low fat is there, we are going to make it as LF, and wherever regular is there, we are going to make it as REG. So similar like that, we will be making all those changes with respect to the anomalies we found with respect to item fatum content. And when we are in a position to so correct all our data to this particular level of addressing all those anomalies, then we will be in a position to train a particular data. So training data, as we always know that already the actual output is there. So our model will also produce a particular output. So there will be always a deviation with respect to that. With respect to the deviation, we will be able to calculate the accuracy or error rate and all those things. So when the training data is in a particular position to produce maximum accuracy or least error rate, then we will be able to go for the testing of test data. So both will be always having different levels of accuracy and all those things. When we are in a position to attain the maximum accuracy with respect to that, so definitely we will be go ahead with that. So before completing this presentation, so we will consider, since it is a regression based problem, because this particular thing is going to produce some continuous value. So here it is not based on a classifier based problem, it's a regression based problem. I have used linear regression for executing our model building exercise for this big mart data sample what we have considered. So if you see, it is taking several seconds for the execution. So once the execution is successfully done, we can see the summary of that particular execution with the help of linear regression. So wherein which we will be able to see the results also. In the interest of time, you might have seen that I have not done all the anomalies, rectification, all those things. Still, we will be able to see some kind of output with respect to the range, with respect to the interquartile range of this particular data. We will be able to see the R square output with respect to the error rate. So there are about 51% of error this has, which means only 49% the results are accurate. So R square results, adjusted R square, so F square, all these results we will be able to see out of this particular execution. So this is how model building exercise would happen with respect to machine learning model building exercises. So as we all know that linear regression is something, a very basic approach that we would consider for a model building exercises. So with this kind of idea, so you will be able to work further on your needs, especially if your need demands all these exercises. So definitely you will be able to do that. So hopefully I have given a brief idea about the programming platform as well as the model building exercise also. So at this juncture, I would like to register my sincere thanks for the organizers for giving me this opportunity, and also my gratitude to all the participants for spending your valuable time on attending this particular session. So thank you very much. So I would be available if you have any doubts to clarify. Thank you very much.
Sir, thank you, sir. 1 second, can you switch on your webcam, sir?
Yeah.
Yes, sir, done. So thank you so much, sir. On behalf of Shri Krishna College of Engineering and Technology, I thank Dr. Durai Raj Vincent for his wonderful knowledge sharing in R programming and explaining the beauty of R programming in statistical analysis. Thank you, sir. Thank you so much, sir.
Thank you, ma'am. Thank you very much.
Sir, thank you, sir. Kavita, ma'am.